Think about a time when you felt happy or particularly rewarded. And this could be maybe somebody gave you a hug, or you received some verbal praise, or maybe you just ate a particularly excellent piece of cake. In any of these situations, your brain was responding in a similar way. Even though you had different stimuli, they all indicated that you were feeling rewarded. So, what we're going to talk about is the reward pathway in the brain. So this is your brain. Pretend you've sliced a brain in half and you're looking at the right hemisphere here. So here's your brainstem, prefrontal cortex, and the rest of it. So what I want to focus on is a few specific parts of the brain. And when you first experience pleasure, your brain releases a neurotransmitter called dopamine. So I'm just going to write dopamine off to the side. So the dopamine is primarily produced in this area, which is called the ventral tegmental area, or VTA. The ventral tegmental area is in the midbrain, and when it releases dopamine in the reward circuit, it actually goes to a lot of different parts of the brain. So one of the places the VTA sends dopamine is to the amygdala. So that's kind of in this area. The amygdala deals with emotions, among other things. It also sends dopamine up to the nucleus accumbens, which is around here. And the nucleus accumbens controls your body's motor functions. Okay, so then we also send dopamine up to the prefrontal cortex, which helps focus attention and planning. And the last area that we're going to talk about where the VTA sends dopamine is the hippocampus. So it's kind of right around here. Just to note, that hippocampus dot should probably be a little closer to the amygdala, a little more to the left. The hippocampus is in the temporal lobe, not the brainstem. We're just drawing it here so it's a little easier to separate out from the other parts that we're talking about. And the hippocampus is responsible for the formation of memories. All right, so now we've set up all the parts of this pathway, and what happens is that when you experience a stimulus and the dopamine in the VTA is released and travels along these pathways, it basically tells your body that this was good, let's do it again. So this is your natural response to some pleasurable stimuli such as food, sex, social interactions. Also, certain drugs, particularly stimulants such as cocaine or amphetamines, can initiate this response. And of course, different stimuli activate this circuit to different degrees. And when we're talking about drugs, that's one reason that some drugs are easier to become dependent on than others. They activate this reward circuit to a greater degree than others. The nucleus accumbens, the amygdala, and the hippocampus are all part of something called the mesolimbic pathway. And as a side note, try not to get too caught up in the terms. These terms like mesolimbic pathway, mesostriatal pathway, sometimes they're used in slightly different ways by different people, and sometimes they're broken down into even more detail. Our purpose here is to hit the highlights, the really important parts of the reward pathway, so I'm just going to use some of the more common terms. Okay then, the mesolimbic pathway is a big part of the reward circuit in the brain. So what happens is the VTA releases dopamine, and it goes to all these different parts of the brain which have dopamine receptors. So they uptake the dopamine, and the result is a feeling of happiness or euphoria, which is the reward you get. So for example, the amygdala, which helps process emotions and is connected to the hippocampus, will say this was a pleasurable sensation, I enjoyed it, and then your hippocampus will say, well, let me remember everything about this environment so we can do this again. For example, let's go back to that excellent piece of cake you might be eating. Your amygdala says, this is delicious, I love this, I'm feeling so happy right now. And your hippocampus says, well, let me remember what restaurant I'm at, what exact piece of cake I ordered, who I'm with. Let's remember things about this experience. Then your nucleus accumbens, which helps control motor functions, says, well, let's take another bite. Let me use my hand to use the fork to get another piece and eat it. And your prefrontal cortex helps focus on that cake and divert some of your attention to it. And then you take another bite, and it's delicious, and the reward circuit goes crazy again, and the dopamine goes out, and that's why you experience this sort of continued pleasure. And one interesting thing to note is that with the continued activation of this reward circuit, we talked about how dopamine goes up, and at the same time, a neurotransmitter called serotonin goes down. And serotonin is partially responsible for feelings of satiation. So this is why drugs can be problematic. When you continually activate this dopaminergic circuit, this reward circuit, your dopamine goes up, so you have this increasing sense of euphoria, but also serotonin levels can go down, which means you're less likely to be satiated or content. What you might notice about this cycle is that it's a very biologically driven process. A long time ago, people used to think that drug addiction was completely driven by a failure of morals or willpower. And while people's choices are definitely strongly involved, we now know that addiction has physiological components as well. It's similar to looking at your family history to see if you might have a genetic predisposition for high blood pressure or something. If someone in your family has high blood pressure or has suffered from a drug addiction, then you may have some increased risk to develop the same condition. However, environment and your choices matter too, so don't worry, nothing's set in stone. Some evidence for the biological basis of drug dependence actually comes from animal models. Scientists can hook rats up to IVs that give them cocaine if they push a lever. And when they do this, rats learn very quickly to push that lever, and they'll even engage in drug-seeking behaviors and will increase their dosage if they're allowed to. What's also really interesting is that negative consequences don't affect an addicted brain in the same way that they do a normal brain. For example, when you give a rat regular food that it likes, paired with a substance that makes it sick, it learns to avoid that food. It doesn't like it anymore. But when you give an addicted rat its favorite drug, paired with a substance that makes it sick, it still wants that drug. So whereas with the regular food, it learns that, oh, something bad happened when I ate this food, I'm not going to do it anymore. With the drug, it says, oh, something bad happened when I took this drug, but I don't really care, I really need that reward. And so what those kinds of studies show us is that addiction seems to take over a rational mind. So what we'll talk about in the next video is tolerance, or how you get accustomed to certain levels of reward, and withdrawal, so how you react when those pleasurable sensations are taken away from you.